this is a flip video about predicting products for double replacement reactions. So let's remember what a double replacement reaction is. Take a look at this example. I have a compound seen here, AB, being added to another compound, CD. What happens is A goes ahead and bonds with D, and C bonds with B. So I like to call double replacement the rainbow, because if you make a rainbow, you can actually see who the new partners are. So now, in other words, your cations have swapped places and are dancing with new anions. So A and D, C and B, outer and outer, inner and inner. Some good things to remember is that you still have to have a cation first with an anion second. Same thing for both of them. Cation first, anion second. You can't have two anions together, and you can't have two cations together. Okay, let's take a look at some examples. Here's our first example. I have NaCl, sodium chloride, and silver nitrate, AgNO3. And if you notice, all of my substances start off as aqueous, meaning they've all been dissolved in water. They're all soluble in water. So let's go ahead and predict these. The easiest thing to do is to draw the rainbow and say that this cation is now going to be paired up with that anion, switching partners, and this cation is now being paired up with that anion. Okay? Over on the product side is where we show the new partnership. I like you to write your charges up on the top so we know what's happening and how to neutralize each compound. Doesn't matter which one you start with. So I'm going to start with the outer rainbow first. Na, and on the periodic table we know that it's in column 1, so it's a charge of +1. Pairs up with now NO3. On my polyatomic ion sheet, I look it up and it's a charge of 1-. I need 1 Na and 1 NO3. So this is all old stuff, making a neutral compound. Okay? Now I'm going to do the next one. I've got Ag bonding with Cl. I pick Ag first because it's a metal. So Ag, and I remember that this is one I had to memorize. Ag's charge is 1+. And Cl, I look up on the periodic table, and notice that's in the column that says -1. So I need one of each, Ag and Cl. Please make sure you show your work in these little bubbles up here on the top. Okay, let's try another example. Let's look at this, and remember, double replacement because I've got an AB plus a BC. If you draw the rainbow, it helps show you the new partners. Okay? Good. So I now have potassium, draw the bubble here, which I look it up on the periodic table has a 1+ charge, bonding with bromine, which has a 1- charge. I need one of each, 1+ and 1- to make KBr. Now I have my next new partnership, and that's sodium with, wow, big polyatomic ion right here. Remember, the cation goes first. All metals are cations. Plus sodium, don't forget your bubble. Cation goes first. Look it up on the periodic table. It's in column 1. It has a +1. And now I need my polyatomic ion chart, or this is one you should have memorized, with a 1-. Cation first, anion second. I need one of each, so I have NaNO3. All right, good. Now, once we're done writing these equations, so if I bring back the first one I did, the next thing we have to do is determine, can this reaction actually occur? I'm sorry, this is the last one we just did. Can this reaction actually occur? When these two compounds react, can they actually make this? And in order for you to say yes to that, one of these compounds has to form into a solid, meaning one has to be insoluble. So let's take a look at some of that terminology right now. Double replacement reactions use what's called the solubility rules. Okay? So in order to understand our solubility rules, I have a couple of important vocabulary words. First of all, soluble means it can dissolve. So soluble means a substance dissolves, and we're talking about dissolving in water. So if a substance dissolves in water, then it's considered aqueous. So if I take salt and I put it in water and it dissolves, which it does, then I can write NaCl with an aqueous next to it. Okay? Insoluble is the opposite. It means it does not dissolve when you put it in water. So it stays as an S for solid. We also like to call this a precipitate forms. So whenever a solid forms, it's called a precipitate. Okay, now that we know our two important vocabulary words and the states of matter that go with them, we can now figure out if a double replacement reaction will occur using my solubility rules I got in class. So these rules are used for double replacement reactions. And there are 8 rules seen here which you do not have to memorize. They tell me whether or not compounds are soluble or insoluble. Okay, so something else important to know, bring back our reaction, is in order for this reaction to occur, like we said a second ago, one of these has to be a solid. Okay, so you need one product as your solid. One of them has to be the precipitate in order for a reaction to occur. If they're both aqueous, then you have no reaction. Okay? So how do we know what are the states of matter? We use these rules. So let's look up potassium bromide. Potassium bromide. So I either can look up potassium and how it acts, or bromine and how it acts. So if I look here at rule number 1, it says all substances containing sodium, potassium, and NH4 are soluble. So any substance that has these ions in it are soluble. Remember, soluble means aqueous. So here is a substance that has potassium, the K plus in it, so it's aqueous. Okay, now this has to be a solid in order to say that this reaction occurred. Is it? Let me see. NaNO3. So I can either try to find a rule that has something about the Na plus ion in it or the NO3 minus ion. So I'm looking over here. Sometimes you could find them in 2 rules. And rule number 2, all substances containing NO3 are soluble. This is a substance that has NO3 in it. It's soluble. Uh-oh, it's aqueous. So therefore, this is what we do. We cross this out and we write no reaction. If they're both aqueous, no reaction. Okay? Let's do another one. Here's the other one we did. Okay. Let's take a look. What are my states of matter? All right. Now, if you notice, I've always started off with aqueous. So in double replacement, you always start off with aqueous. So that's something you know. You always start off with these solids dissolved in water. That you know right off the bat. You don't look here for that. Okay? It's the products that I look at my rules for. I just told you that all substances, rule number 2, with nitrates in them are soluble. Here's a substance with nitrate. It's soluble. Soluble means AQ. So that was easy. Now I need to find a rule that either has silver, Ag plus 1, or chloride, Cl minus 1 in it. So I look. Here's a rule. Substances containing chlorides are soluble unless they contain Ag plus. Okay? Well, here is Ag plus, and here's chloride. So therefore, it makes it insoluble. So if it's not soluble, it's insoluble. And insoluble gets an S. So this reaction occurs. You might want to write that down because one of the products formed a solid, the reaction occurs. The reaction occurs because one of the products forms a solid, the reaction occurs. Hopefully you can read that. Let's push this up here. Okay? There you go. That's the end of your video.